there have very recently been some bug fixes in JMRI that have made using JMRI over TCP/IP based protocols much easier and straightforward, and much more similar to how it works over RS485, at least from a code point of view. As far as I know, that those updates still aren't actually released yet. They're not in 5.3.5 test release, and they're not in 5.2 production release, but they should be in the next releases after those releases. So once I'd started looking into Wi-Fi, I must admit I'd kind of assumed that, like these Ethernet boards that I bought for the Arduino to get it working over Ethernet, I thought there'd probably be a Wi-Fi board much the same as that I could buy and plug in, but I can't find one. There are shields that are based on the Arduino Uno form factor, but I think even they've possibly been discontinued. They're not so easy to get, and they're still quite expensive. I'm not keen on moving to the Uno form factor either, because I've got these messy sensor shields on top anyway, and I don't think they would be compatible. I think there is a new Arduino model out, the Giga, that has the same form factor as the Mega and has Wi-Fi built in, but I think they're possibly not even available yet. And even when they are, they look like being around the £70 mark, and there aren't any clones of them available yet. So that's possibly overkill for me. I did recently have some very interesting conversations with someone about the Nano Wi-Fi board that's available, and I think that would really be a very realistic contender. I just didn't really know about it when I headed down the route that I went down, but I think that everything that I'm going to explain in here is still very relevant to the Arduino. I'm kind of going to do some stuff that's specific to ESP32 boards, but I think anyone who wanted to do this, the Wi-Fi over CMRI approach, would just need to ignore those very specific ESP32 steps. I think the core code in the Arduino IDE would work either on an ESP or on an Arduino. And so I ended up going down this route, the ESP32. This is an ESP32-WROOM or something. Again, I'll include a link. The thing that was really appealing about it was that it's relatively inexpensive, 3 for £21. I think this came in at. And the really clever thing about it is it can be made compatible with the Arduino IDE. Obviously, any board that I bring in onto the layout, I want to be able to share the source code, the code I've already written for Arduinos. I want to share onto any other board that I bring on. And it does appear that the ESP support that by adding installing extra files on the Arduino IDE. These boards can be made to compile the same source code, the same C++ that's in the Arduino IDE, and run it locally, and also share all of the libraries, especially like the Wi-Fi one, which is especially important. Something else that's important to mention is these run off a different voltage to the Arduino boards. These run off a 3.3 volt operating voltage, so any accessories I've got around the layout that run on 5 volts, which most of them do at the minute, I couldn't plug straight into the GPIO pins on this board. I would have to make sure that if they were powered separately from this board, like say the infrared sensors are, then they would need to be powered off a 3.3 volt power source, not the 5 volt source that they're currently supported. This board doesn't tolerate 5 volts and will fry. So similarly to how the Arduino boards work, these devices can be plugged into a computer for uploading and console monitoring via USB cable. These ones take a micro USB cable, and they can also be powered from that cable as well. I think they have separate 5 volt inputs, which via pins, which I'll use once they're under the layout. But for now, I'm just going to get it connected with a USB cable onto the computer so I can start testing it and seeing what it can do. I'm now going to get my Arduino IDE configured to support the new ESP device. I think I might also have to install a driver or two, but we'll go with Arduino first. So this is I think again, this my understanding of this is an ESP32 board is a completely different board to an Arduino, but there have been extensions written by Espressif, the people who kind of came up with the chip, I think, in order to make the Arduino IDE support the ESP. Now that's beneficial, especially for someone like me, because I use both devices for the same thing. Effectively, I write sketches for MQTT, for CMRI, for general accessory management on the layout, and if I can use pretty much the same code for an Arduino as I do for an ESP32, then that's beneficial to me. There are other development environments and other languages you can use with ESPs, but to me it's more convenient to stick with the Arduino environment that I'm used to. So I need to install those extensions in the Arduino IDE so that so that it will talk to and compile for the ESP. And the easiest way I've found to achieve that is to add a JSON URL into the Arduino environment here, which gives it an address to go to get lots of information about add-ons that it can download and install. So I'll paste this. This is the most useful one I found. It's always worth sometimes, because that's a URL that I don't know where that's come from, so I was a little bit skeptical about it. And what you can do with these things is you can, any kind of JSON URL like that, you can paste into a browser and you can have a look through what it's actually doing. So this is information that is being passed into the Arduino kind of set of instructions of things to do. And the important stuff is it's downloading from the Espressif GitHub, which is good. I did double check. This is the latest version of the executables, the downloads that are on the GitHub. So and then I think there are just earlier versions down here. But that's a good sign, and it saves me downloading and manually extracting and putting them in the right place and that kind of thing. So I'm going to leave that URL in there. I'm going to click OK. Then what I need to do is click on Tools here and Board, and click on Boards Manager. And there'll be lots of additional libraries here now that I can install, and what should be there is the ESP32 library, and there it is. That's by Espressif, which is a good sign, and it's made this 209 available. It's aware of it now, so I can now install that library, and I think this might take a little while. It's now installed for the ESP32, so if I click close, I don't know if it'll show me the boards I have available right now. Yes, it does. So under here now I've got ESP32 Arduino boards available, and I've kind of taken a bit of a guess here because the boards that I bought had the word room in them, so I've opted to select that board. However, the board might not yet be visible to the Arduino IDE because I think I had to install drivers for that that board. And I have a web page here. I want the CP210. In fact, if I go to Device Manager in here, sorry, if I go to Device Manager in here, maybe ports. Oh no, maybe that's a Windows 11 thing, because on my Windows 10 PC that didn't happen, but it has detected it. However, on Windows 10 I did have to download the driver and update it manually, and I'll include a link in the description to the web page where I had to do that. But that's a good sign. So that looks installed now, and if I go to Tools, it gives me, these things are slightly more complex beings, I think, so there are a lot more options here, but I can just, I've always just ignored these. I don't need to worry about them, but I do need to select the port, and I think I probably just had that information, did I, in Device Manager? Let's go back to it. Ports, and I'm looking for that one, so that's on COM6. So down, select port 6, COM6, and I should, in theory, if I go down to examples for this board, maybe a simple Wi-Fi scan. I think there is a Wi-Fi scan demo here, and I try uploading that to the board, which is connected. And that's not a good sign. So I think I need to go off and read the instructions. And a quick Google later, I've discovered that there is a boot button on these ESP32 devices, and sometimes you need to hold them in while trying to upload to them to put them into the right mode to accept the uploading of a new sketch. So it's a strange one because I didn't have to do it on my Windows 10 PC, but I do have to do it on the Windows 11 PC. But it's just a case of when that connecting message and the dots appear during the uploading process, I held the boot button down for a few seconds, and that connected the two of them up, and that got the sketch uploaded. Now that's uploaded, then it's just a case of opening up the COM port and putting the right baud rate on. And I should now be able to see how this sketch is running, and this is a nice easy one because it doesn't require any authentication or anything like that. It just scans for local Wi-Fi networks and continually displays what it finds. So I can see, I recognize some of those SSIDs, so that's another good sign that the sketch is doing what I would expect it to do, and that the uploading works, that the compatibility with the Arduino IDE works, and that also the actual Wi-Fi chip on board the ASP appears to be working too. So far so good then. I've got to the point where I can see my Wi-Fi networks and a few of my neighbours as well. So the next step is to see, can I actually connect to it? And I found this example called Wi-Fi Client Connect. I'm still at the point really, I tend to be like this with a new device that I don't really know and don't really trust. I just want to take it step by step, use library examples so that I'm not bringing the catastrophe that is my own code into the equation, and just go up in little increments, little steps, make sure this stuff works before I get to a point where I might think, okay, I'm confident enough with this thing to try and do what I want to do with it. So what I like about this particular sketch is it's got lots of debugging as to why I might not be able to connect. So if something goes wrong, it will give me a good reason as to why that went wrong, which to a pessimistic mind like mine is quite useful. So the only thing I need to do is paste in my SSID and Wi-Fi password, and I'm hoping that at some point between now and when this video is published on YouTube, I'll learn how to hide certain bits of the screen, and I'm going to try and upload that. I have noticed actually that compiling and uploading takes quite a lot longer on these devices than it did on the old Arduinos. And there we go, uploaded. It's probably worth pointing out at this point as well that I'm back down on my office PC now, since I did those first couple of examples. And on this PC, I don't need to press that boot button on the ESP32s. The upload just seems to work, which is strange but easier. So I'm going to get the console up, and I've probably got it on the wrong. No, I've got it on the right baud rate, but I've got nothing here. So I do think there's a reboot button on the device that I'm gonna press and see if I can get it to come to life. That was the reboot button, and there we go. That's worked, provided I press the right buttons the first time. And the way to something that's very encouraging down here is it has an IP address. It's gone through DHCP. There's no static IP in these sketches, but it has managed to establish through DHCP an IP address that I know is recognizably on my own subnet. If I go and do a quick IP config, in a window that's on this monitor, I can see that the IP address of this computer is 100.19. The IP address of the Wi-Fi device is 100.41, which is a good sign. And the last thing that might be useful to do is go down to 141 and ping it. And if I'm getting a reply, the two are talking on the same subnet, same network, which is even better. I'm starting to trust the board then. So now I think I'm at a point where I want to actually make it do something useful, and in this case it's to establish this CMRI over Wi-Fi connection. So I'm going to go straight back to the examples again, and I'm going to use the same as I did with Ethernet, use this Hello World example that's already in the library by Michael Adams, and adapt it to use Wi-Fi this time instead of using serial or RS485, whatever might get passed through it. This is my code then, and really it's very similar to the Ethernet approach that I did, except, I mean, really, pretty much the word Ethernet is swapped for the word Wi-Fi. There's not much difference in there. I have so a couple of consts here, my SSID and my password, and I'm scrolling, so it's going to make it even harder to hide it. TCP port, I've just gone one further on than I did with Ethernet, so it's on TCP port 9007. Here we're starting the Wi-Fi server. Again, we need to provide, JMRI expects us to provide a server. JMRI acts as a client, so we need to provide a server for it to connect to, so that's what we're setting up here. And when JMRI as the client tries to connect to our server, we need to create an object that represents JMRI as the client, and that's what this is doing here. Very similarly to before, we're going to use the CMRI library, and we're just going to pass in our JMRI client, because again, the Wi-Fi client, there's some assumption here, the Wi-Fi client is a derivative of the stream class, which CMRI accepts because it can either accept serial buses or Auto 485 objects, the other library Michael Adams created. So in order to do that, I think it accepts any derivative of the stream class as the Wi-Fi client is, so we just shove that in. Wi-Fi begin with the SSID password. I copied this from a couple of the examples just to get it connected up, and then we have the little bit of debug saying that we're connected and what our IP address is, which is quite useful because JMRI will need to know that. I've got exactly the same, wait for JMRI. I think that is a literal copy and paste from the Ethernet example. So this is just a quick routine that will check to see if JMRI wants to connect and accept it as a connection. If it does, I think it will also support, I'm pretty sure I've tested it, it will support reconnections by JMRI as well. So if JMRI was to restart, this would handle that. Setting pins exactly the same as we would in a normal CMRI based sketch, and also a set bit here which updates the state of the sensors that will be sent back as a response to a poll. Now the headline here is this won't work. I thought it would. I tested it, I got it up and running. I got responses to commands, turning LEDs on and off working, but as soon as polling was switched on, I got an error in CMRI and in JMRI, and it lost its connection. And the reason why there is an error, going back to the CMRI library, is in the actual transmit. So transmit, coming down here through the code, if here's transmit, so I've probably missed process, but as part of the CMRI process, this method here gets called, and you can see here, if it detects that there was a poll, it transmits, and that's its response to a poll. Down here in the transmit, all of this works pretty well. This is a line that needs to be discussed, however. I will come back to that one. The response is prepared and it's sent, and it's actually this line. Now for serial is an internal variable name, and in our case this actually represents our Wi-Fi client, so it's sending this down the Wi-Fi client, and it's this line that causes the error in JMRI. It looks like Wi-Fi library's done like a flush. What that means really is, from my point of view, the quickest solution to this was to, instead of use this as a kind of closed library, add it into my add the two files needed into my project so that I can then change them. And the very quick easy way to do that is, for both of these we need CMRI.cpp and we need CMRI.h. So what I'm going to do here is I'm going to stop using it as a reference library and I'm going to add it as an editable library in my sketch. The easiest way to do that, so this is CMRI.cpp, so I'm going to click on raw so I can get the whole lot. I'm going to click Control A to select it all and Control C to copy it into the clipboard, and I'm going to go back into the that's not the one, is it, into the CMRI server, and I'm going to add a new file here, new tab, and I'm going to call it CMRI.cpp, and I'm going to paste that code that I just copied into there. I'm then going to create a second tab here and I'm going to call it CMRI.h, and I'm then going to go back into the library in GitHub, and I'll include links to this, and I'm going to go and get the CMRI.h file, click on raw again just because it's easier to do a Control A, copy it all into the clipboard, back again to this, paste it into there, and I now have that library inside that entire Arduino CMRI library inside my sketch effectively, so I can start editing it and changing it. So the first thing I'm going to do is I'm going to comment out this serial.flush because I know it doesn't work over Wi-Fi, and that gets rid of it. Now this delay line, I've discovered this recently, and I did a video a while back on slow turnouts, so adapting servos so that they don't quickly move and they move gradually. And the net result of that was, especially as more servos are added, they kind of moved jerkily. They moved in jerks, and then they stopped and then they started again. It wasn't smooth movement, and I believe it's actually, now I've seen it, because of this line here. This transmit void will be called 4 times a second because it's a response to a poll, and a poll happens 4 times a second. So what that means is, for every 250 milliseconds that the Arduino is working, it's actually doing nothing for 50 of them. It may be required, over serial and RS485. It may be required over Wi-Fi, but I can always come back and uncomment it. So for now, I'm going to remove that line, because if I do have or end up with sketches on using this library that want to support smooth servo movement, I need to get rid of that line. So that's my library adapted. The last thing I need to do is switch right up at the top here. I need to stop my sketch using the CMRI default library that is downloaded and installed as a library, and to use these files instead. And the way I do this is I get rid of these chevron things, greater than and less than signs, and I replace them with quotes, and that's saying use this local file. So this sketch is now using, instead of that old the standard Arduino CMRI library, it's using the adapted one here, which gets rid of those this line in particular, which stops it working, and this line, which might make it a little bit more efficient. So I'm going to compile this. There we go, that's compiled. So again, remembering, when I compile, I need to make sure that my board is selected, because it compiles it against that board, and it compiles the machine code that comes out of the other end. If you have that board selected, it knows that it's compiling it for the right board. So now that's compiled again, it's going to compile it again, but I'm going to upload it to my board and start testing. In order to test, then I'm going to need to set JMRI up in for this Wi-Fi connection. So I'm going to create a new profile, like I need more profiles. Let's call it CMRI Wi-Fi test, and create a blank profile which may appear somewhere and has appeared here. So
ignoring everything else again, all of the connections, I'm going to create once again a CMRI connection, and I'm going to create on a network interface. I can remember that the IP address that it kicked out, it's very useful because it does tell you what IP address it's using. If I go and find this might be hard to do, but let's see what's happening on the serial monitor. I might need to reboot it to get it to spit out which IP address it's using, and I can't even find it because it's tucked away behind my monitor. There it is. So if I just press the reset button, I think, on this Arduino, there we go. It goes through the connection and it tells me there that's its IP address. So I know I need to put IP address 192.168.100.41 in there, and I can remember that the port that I specified in the sketch was 9007. It would probably be a good idea to add a node at this point, so let's just go and add a standard one and just keep dragging these windows when they appear on the wrong monitor. And again, I went through polling in the Ethernet video. Polling, I guess the short version of it is it now works, and it's easier to leave polling on. You will need less code in your sketch if you leave polling on, and I'm going for the least code approach here, so I'm just going to leave it on, and that's it created. And I'm going to click done, and I think that's all my config done, so I'm going to save and it'll ask me to restart. So let's restart.
And down here on my workbench of ever increasing projects, I've got my ESP device, which is communicating to JMRI over Wi-Fi, but it has this USB connection at the minute for power, but also a little bit of console output as well. I've got a micro switch connected up on the top there, which is actually attached to a mount as well, but it has a micro switch on it to test sensor input. And I couldn't get, I don't know what I'm doing wrong, I couldn't get the onboard LED. Apparently the LED or the pin number on these boards is 2, whereas on 13, on the Arduino it was 13. But even using 2, I couldn't get the onboard LED to light up, so I've just got a little breadboard with an LED plugged in, and because it's 3.3 volt output, I haven't bothered with a resistor. It's just directly powered from the ground and 3.3 volt outputs on the Arduino ESP.
And JMRI has restarted then, if I drag it over here, and this is a good sign as well, because I got some feedback here that it has already connected, and I've got a good sign here. There are no red lines and no error messages. There won't be any polling or anything yet because we haven't got any hardware set up, any accessories set up on here, so it's time to start that now and go through exactly the same process as I did with Ethernet. I'm going to add an LED, and I'm going to drag the window over again, and I'm going to create it at 1001. Let's just call it LED. Create that and close, and straight away I should be able to turn this LED on and off, and indeed that's a good sign. The LED is responding. The one on the ESP isn't, but the LED in the board is. So now I'm going to go and create a sensor, and this should mean that polling starts as well, so we can make sure that there are responses coming from the polls that are being sent. So as soon as that gets created, if I go to CMRI and monitor, again, the good news here is I can see that polls are being sent. What I should see as well, because I commented out that they look like they're not going through quickly, but actually they are. It's just because the text is kind of the same shape, but if I put the timestamp on, you realize how quickly these things are going through. And just out of interest, because that 15 millisecond delay is taken out, what I will probably be seeing is a much well, actually strangely about the same response time. Sometimes it does drag down, but we're going over Wi-Fi, so it might not be as instant as it would be over RS485, but see, sometimes we're getting a very low response time, a ridiculously low response time in fact as well, which maybe I would have expected, because I think from memory on RS485 the response time was about 70 something milliseconds, but that included the 15 millisecond delay that was put in by the CMRI code. So that's looking pretty efficient. So next thing to do is go and test and make sure that there is actually a response from the sensor. So I think the table's up already. This should bring it up. So there's my sensor, and it's currently set to inactive. So I need to grab this thing and find the micro switch on it, which is there. Just press it in, and that's looking good as well. I'm getting a response in the sensor in JMRI to a press of a micro switch attached to the ESP board. So that's inputs and outputs over CMRI working over Wi-Fi.
And I think really that covers everything, maybe except to say that this example was very ESP32 specific, but actually the whole point of integrating the ESP32s into the Arduino environment is that you don't need to worry about the source code. So I suspect, although I don't have one, I suspect that just commenting out that using the ESP library up at the very first line, I think, of the sketch, and just not following the ESP specific steps like adding the libraries and installing drivers, that kind of thing, I see no reason why that sketch wouldn't work perfectly on an Arduino Nano, for example, that has Wi-Fi enabled. And I'd be very interested to hear if anyone did get that working successfully.